Hey, welcome to the 14th lesson on C++. Throughout this lesson, we will learn how to work with data structures in the C++ programming language. Sometimes in programming, there arises a need to describe a small object. It could be anything, a book, a table, or even a tree. And it may seem like, well, what's there to describe about every object? But even for a tree, there is a set of characteristics. Its age, name, information about who planted it, its height, and so on. To describe such an object, you might create multiple variables or arrays, add values to them, and thus describe the characteristics of the tree. Now, let's imagine that in our program, there isn't just one tree, but 20 trees. In that case, you end up with a vast number of different variables with different names. At some point, you might get confused about what belongs to what. To avoid such confusion, in the C++ language, there are things called data structures. With a data structure, you can describe the basic characteristics of any object in one unified place. Then, based on the structure, you can create specific objects, for example, an oak, a fir tree, and so on. For each of these objects, you can add specific values. The first thing we will do is write a structure. Essentially, we are abstractly describing an object. In our case, let's describe a tree, as we just talked about it. To create a structure, outside any functions, we write the keyword struct. Then, we specify the name for our future structure. My structure will describe some abstract tree, not a specific one like an oak or a fir tree, but just any tree. After the name of the structure, I open curly braces. Note this exception: for structures, specifically after the closing curly brace, you must put a semicolon. As you might have noticed earlier, in functions, conditions, or loops, we never put a semicolon after the final curly brace. Here, it is necessary, or there will be an error. Now that we've created the structure, we can describe certain characteristics within this structure. Let's say that any future tree must have a name. We don't need to specify the actual value here, we're just indicating the characteristic that some tree will have a name. Additionally, let's specify a variable ages where we'll indicate the age of our tree. Additionally, we'll store information about whether this tree is alive. Let's also specify that our tree will have a certain height. Create a variable for this, height. You can add any other characteristics here, but for now, let's limit ourselves to these. Now, based on this structure, we can create specific objects, where each specific object will represent a specific tree. Each tree will have all the characteristics we described inside the structure. To create an object based on the structure, I need to specify the name of our structure as the data type. In our case, it will be tree. After that, we specify the name of the object. Let's call it oak. Finally, we put a semicolon. Now you can see that we have created our first object, and this object now has access to all the properties we recently created in the structure. Let's make sure of this. To do this, I need to refer to our object and, using the dot notation, I have access to all these fields. Let me set values for some fields. For example, I'll say that the name for this tree will be oak, which makes sense. Also, let's specify the age. Let my oak be 24 years old. You can set other data, and I'll limit myself to these two values for now. In the end, we have just created a specific object with characteristics. If I need to create another tree in the future, I will simply write below here, tree, and let's add, fir tree. Then, for this object, in the same format, I can set new data. Let's specify the name, fir tree, and also specify its age. Let our fir tree be 5 years old. Now, if I try to output data from the first and second objects, you will notice that only the data related to the object I am currently working with will be displayed. Let's output the names of our oak and fir tree. We see that first, the oak is displayed, and then the fir tree. Another convenient aspect is that you can place functions inside the structure. Once you place a function here, it will be accessible to all objects created based on this structure. Let's consider this. Suppose we have a simple function that prints information to the screen. Let's call it getInfo. Here, we will print the name field to the screen. You can print other variables as well, but for now, I'll limit it to this variable to keep the lesson concise. In general, you can print any data and any functionality you want here. Now, instead of printing data as I did earlier, I can refer to the first object, let's say the oak, and call the getInfo function. This way, I will print all the information regarding our oak object. Similarly, let's refer to the second object and also print the information. Now let's run the program and verify that it outputs the names of our objects. The convenience here is that we added functionality in one place, and it immediately became accessible to all our objects. In this lesson, the key takeaway is that through structures, you can create abstract blueprints where you describe a certain object. It could be a tree, a table, a computer, and so on. Then, based on these structures, you can create objects, and for each object, you can add different characteristics. Later, you can work with all these characteristics as you see fit. You can display them on the screen, perform mathematical operations, and any other actions. And overall, our lesson comes to an end. I hope you enjoyed it. If so, don't forget to subscribe to the channel and like this video. Until we meet again, goodbye.